This lesson on spoke-to-spoke via hub topology will define the concepts related to spoke-to-spoke via hub topologies and describe how to configure and monitor spoke-to-spoke via hub. At the end of this lesson, you will be able to define the concepts related to spoke-to-spoke via hub only, describe spoke-to-spoke via hub spoke groups, and configure a device as a spoke-to-spoke via hub device. The spoke-to-spoke via hub topology allows spokes to communicate with each other, but only through the hub. To communicate with a remote branch, traffic is forwarded to the hub, and the hub redirects the traffic towards the destination branch. Tunnels are only created between the hub and spokes. To enable this capability, the next hop for all LAN routes must be the hub device. LAN routes received on the hub from branch devices are processed on the hub and then re-advertised by the hub to branch sites, with the hub set as the BGP next hop or SD-WAN gateway. The key difference between the spoke-to-hub only and the spoke-to-spoke via hub topologies is that in the spoke-to-spoke via hub topology, LAN routes from all spokes are advertised to all spokes by the hub. Each device in the SD-WAN is configured with a routing policy that rejects routes advertised by remote CPEs. However, with this topology, the hub site is configured to accept routes received from remote CPEs and to re-advertise the routes back to the Versa controller with itself labeled as the source of the routes. Although the CPEs in the domain are configured to reject routes advertised by remote CPEs, they are also configured with a policy that accepts routes advertised from the hub site. The spoke-to-spoke via hub topology modifies the route policy to allow LAN routes from spokes to be seen by other spokes. However, a spoke-to-spoke topology is not built. The same import policies are in place on spoke devices as in a spoke-to-hub only topology. Routes are still advertised to all devices, and all spokes reject node and LAN routes advertised by other spokes. All spokes accept routes advertised by the hub. With spoke-to-spoke via hub, spokes advertise their node information and LAN routes to all other devices in the SD-WAN through the controller, as with other topologies. As with the spoke-to-hub only topology, node advertisements from other spokes are rejected by BGP policy, as are LAN routes advertised by other spoke devices. The rejection of the node advertisements prevents spoke-to-spoke tunnels from being created. The node advertisement from the hub is accepted by all spokes, and therefore tunnels are created between spokes and the hub device. In a spoke-to-spoke via hub topology, spokes modify a community value in the routes advertised to the SD-WAN. The new community value allows the hub to accept the LAN routes and re-export them back into the SD-WAN with the hub set to the next hop to reach those addresses. This makes the remote LAN routes appear to be directly connected to the hub device from the spoke perspective. The key difference between spoke-to-hub only and spoke-to-spoke via hub topologies is how the hub processes routes. The image shows a standard device virtual router layout on the left and a hub device virtual router layout on the right. When a hub is created, a separate LAN VR is created that doesn't have any physical interfaces, but it acts as a locally connected LAN. A policy is created that examines incoming Layer 3 VPN routes from spokes to determine if the spoke routes should be moved from the LAN VR VRF to the LAN VR export VRF. With a spoke-to-hub only topology, spokes only tag LAN routes with a community value that does not match the policy used to move routes from the LAN VR to the LAN VR export table. Therefore, no routes are moved to the LAN VR export table and the table remains empty. When a spoke group is changed to a spoke-to-spoke via hub spoke group type, the spokes add an additional community tag onto the routes sent to the hub. This new community tag matches the policy to move routes from the LAN VR to the LAN VR export table. Once the spoke routes have been moved to the LAN VR export table, the hub re-exports the routes back to the SD-WAN with a new VRF target community and a new route distinguisher, which makes the routes unique in the domain. Since the routes originate on the hub device, The hub device is the gateway to reach the advertised LANs, and the LANs appear to be directly connected to the hub device. The results of the spoke-to-spoke via hub configuration are similar to the spoke-to-hub only, with a single exception. LAN routes from all spokes are seen on all spokes, but they appear to originate on the hub. Just like other hub and spoke topologies, node advertisements between spokes are rejected, so tunnels are only created between the spokes and the hub. The LAN routes from spokes are accepted by the hub, moved to a new LAN VRF in the hub, and re-exported back to spokes with the hub as the originator of the routes. Because traffic forwarded to the hub arrives in the hub LAN VR, and the other spoke routes are also present in the hub LAN VR, the hub can turn around and forward traffic received from one spoke back to the destination spoke. To configure a spoke group to perform spoke-to-spoke via hub functions, assign the spoke group type as spoke-to-spoke via hub. Other configuration parameters are unchanged, and the workflow automatically creates the correct policies, VRF target communities, and other BGP communities. As mentioned previously, the hub policies do not change when changing spoke group types. Only the values and policies on the spokes change. The spoke policies and communities determine how routes are processed in the different hub and spoke topologies. With a spoke-to-spoke via hub spoke group change, a new community value is added to routes that are sent to the hub, which allows the hub to move routes between the local LAN VR and the LAN VR export routing tables. On the spoke device branch 102, the routes to the LAN Z resources are present with a next hop of the hub. Also, the LAN B resources of network 192.168.103.0/24 are present, which also have a next hop of the hub. This is because the hub accepted the routes, moved them to a different LAN VR or the LAN VR export table, and re-exported them to the branch 102 spoke. The image shows the dynamic tunnels created on spoke branch 102. As with other hub and spoke topologies, the node advertisements from other spokes are rejected by all spokes, so other spokes are not present in the SD-WAN topology. Only tunnels to the controllers and to the hub are present on the spokes. The image shows the route information present on spoke branch 103. Routes to the LAN networks connected to the hub and to spoke branch 102 are present in the routing table, but they are both learned from the hub, and the hub is the gateway to reach both destinations. Like with the branch 102 spoke, the branch 103 spoke only has tunnels to the controllers and the hub. The routes from all spokes are present on the hub device. The key difference is that now the spoke routes are tagged with a community that allows them to be exported to the LAN VR export routing table as well, which is not shown here. The hub device accepts all spoke node advertisements and therefore can build dynamic tunnels to each spoke device in the SD-WAN. You have reached the end of this lesson. In this lesson, you learned the spoke-to-spoke via hub topology allows spokes to communicate with each other but only through the hub. To communicate with a remote branch, traffic is forwarded to the hub, and then the hub redirects the traffic towards the destination branch. The hub configuration for spoke-to-spoke via hub is the same as with other hub configurations. The policies remain the same, and all of the processes remain the same. The difference comes with the spoke configuration and the communities added to routes advertised by the spokes. And to configure a spoke group to perform spoke-to-spoke via hub functions, assign the spoke group type as spoke-to-spoke via hub.